In lesson 15, we're going to convert improper fractions into mixed numbers, but we're not going to use long division like most people are used to. Instead, we're going to use a visual approach that makes a lot more sense. Before we begin though, let's go ahead and compare the two methods. Here we have the fraction 7/3, which is an improper fraction because the numerator is larger than the denominator. 7/3 can also be read as 7 divided by 3. So let's write that down as a long division problem. Here's 7 divided by 3. 3 goes into 7 2 times. 2 times 3 is 6. 7 minus 6 is 1. The next step would have been to do 1 divided by 3. So just write down 1 divided by 3. And here's your answer, 2 1/3. The problem with doing it this way though is that even though it gives you the correct answer, this makes absolutely no sense to students and it's just a bunch of numbers to them. So we're going to try a more visual approach instead. Here, notice that we start with the same fraction of 7/3 and we're going to break it up this way. We're going to write blank over 3 plus blank over 3. And this makes sense because thirds plus thirds give you thirds, just like apples plus apples give you apples. Now think about this. Can you do 7 divided by 3 evenly? The answer is no, so you're going to count backwards from 7. What's 1 less than 7? And that's 6. Can you do 6 divided by 3 evenly? The answer is yes. So write down that 6 right away. Now, 6 plus what number will give you 7? And the answer is 1. And let's just check to make sure this makes sense. Thirds plus thirds give you thirds. How many thirds? 7/3. So this makes sense. Let's go to the next line. What is 6 divided by 3? And 6 divided by 3 is 2. So write it down nice and big. And what's left over? Here we have 1/3. And this is the same answer that we got earlier. As I've explained before, procedures like this will not stick unless you actually show students what it means. So let's use our fraction circles to help us out again. Here was our original fraction of 7/3. And students, count along with me. We have 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, and 7/3, which again was our original fraction. And after we did all this work, we ended up with 2 1/3 as our final answer. The question now though is, this 2 in our answer, where did that come from? Because I'm looking at our fraction circles and I don't see a 2 anywhere. I see 1, 2, 3, 4, 5, 6, 7/3, but I'm not sure where that 2 came from. So I give students some time to think, and invariably someone will say, oh, you can actually put these pieces together. So let's take these pieces together and make one whole circle, and put these pieces together and make 2 whole circles. Then you've got this one little piece left over. So now when you do the demo this way, it becomes a lot more obvious where these numbers are coming from. This 2 here came from these 2 whole circles that we created by putting the pieces together. And this 1/3 is that 1/3 piece right here that's left over. So it becomes much more clear where the numbers are coming from. The 2 came from 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, which is right here. And there's the extra 1/3. So this is a much more concrete and intuitive way of converting improper fractions to mixed numbers. Let's go over one more example. Here's our second example. We have the fraction 8/5, and we're going to break it up this way. Since we're working with fifths, we write blank over 5 plus blank over 5. And this makes sense because fifths plus fifths give you fifths. Now, look at 8 divided by 5. Can you do that evenly? No, so count backwards from 8. Counting backwards, next is 7. Can you do 7 divided by 5? No, keep counting backwards. 6 divided by 5. That doesn't work, so keep going backwards. 5 divided by 5. Can you do that evenly? Yes. So write down the 5 right away. Now, 5 plus what number will give you 8? And the answer here is 3. Let's see if this makes sense. Fifths plus fifths give you fifths. How many fifths? 8 fifths. So this makes perfect sense. Let's go on to the next line. What is 5 divided by 5? And that gives you 1. Write it nice and big. What's left over? We have 3 fifths. So our final answer here is 1 and 3 fifths.